Hey Finxters, what's up? It's Chris, founder of Finxter.com, and in today's video I want to introduce you to Python's reduce function. So the reduce function, it's a great little helper function, and it is like it actually opens up all ways of using functional programming in Python, and it's very popular these days, even though Guido van Rossum, Python's creator, Python's godfather, didn't particularly like it. I have written an article about this. It's an article about the article where Guido van Rossum has actually argued about the fate of the reduce function and why he removed it from Python 2 and put it into the func-tools library in Python 3. So if you want to use the reduce function in Python 3 and beyond, you need to import it. You need to import the func-tools library, and you can then use the reduce function via func-tools.reduce. Okay, but first of all, I want to give you an overall rough idea of the reduce function, how it works, and how you can use it to reduce an iterable, so like a list of values, to a single value. It's a very powerful concept that is even used like in distributed systems in the MapReduce framework to facilitate people to access distributed functionality, so they only have to define the map and the reduce function in the MapReduce framework, and the MapReduce framework then automatically distributes computations among many computers. But this is like off topic a bit, so let's dive into the reduce function. So say we have this list of values 1, 2, 3, 4, 5, 6, and we want to reduce them with the easiest possible aggregator function, which is the plus function. Okay, so then we start with an initial value. It could be like 0, or it could be the first value like this one. And then we reduce it by using a reduce aggregator function. And in this case, I will just use a plus function as an aggregator function. Okay, so I will reduce those two values. I just take two values from the sequence. It can be arbitrary values, but usually it will be you start from the left and go and work your way to the right. So I just take those two values, reduce them to their sum, which is 3. And then I repeat the same procedure, because now my iterable has one value or one element less than previously. So now over time I will ultimately, if I keep repeating the same behavior, I will reduce the whole sequence to a single value. So I just perform this reduction now. Again, I use the plus operator on both and put them together. So 3 plus 3 is 6. Then we put those together. 6 plus 4 is 10. Then I put those together, so the reduced value 10 plus 5 is 15. And then I put those together, those two values, 15 plus 6 is 21. And so I get a single value 21, which is the reduced value when using the aggregator function plus. And of course we can use many different aggregator functions. We could also use average or median, even some more advanced stuff. Like even you could have, if you have string elements and you would use plus, you would actually do the concatenation of all values in your list. But let's have like this conceptual example. Let's close this whiteboard and have it in our code. Okay, so I would just use the same example I introduced to you and create code actually that does it for us. So first we import the reduce function from the func-tools module, and then we define like our aggregator function. And in this case, it can be a sum function, and our aggregator function is now required to take two input values, because you have seen we took two values from the iterable and reduced those values to a single one. And by repeating this process, we actually we create a single aggregated value that consists like that arose because of the repeatedly appliance of the aggregator function. So let's call this aggregator function mySum. We take two values x and y, and we simply return the sum of those two values. And as I said, it can be arbitrarily complex, it can be very simple. So you would be surprised what you can actually do with the reduce function. And we will examine some more advanced ways of aggregating lists and of using the aggregator function to do some more sophisticated computations later in this video, but let's maybe stick with the basics for now. And so say we have now some values like in a list 1, 2, 3, 4, and we want to reduce them to a single value, so we calculate the total. We call the reduce function, and what the reduce function takes two arguments in its most basic form. The first one is the aggregator function, and the second one is the iterable. So now this is just some dummy values that you need to replace. So what is our function? So remember, in Python everything is an object, functions are objects, so we can simply pass a function into it. This is our aggregator function. Python will use this aggregator function mysum to actually repeatedly combine two values from the iterable. So now we need to define the iterable, and of course it will be values. It will be values. So now now actually we are done. If we run this, we have in our total variable we have stored the reduced value of 10. Yeah, so we have we basically, the steps are the following. So first of all, I now do it manually, right? So first of all, we start with 1 plus 2, which is 3, and then we start with 3 plus 3. We proceed with 3 plus 3, which is 6, and then we take 6. Like we always take the result, and we add another iterable element, which is like the last iterable element is 4. So we compute 6 plus 4, and we obtain 10. So Python basically does exactly this, same steps, same sequence. Okay, so I hope that by now you have understood basically the basics of the reduce function. We pass a function, like a function argument, an aggregator function. I call it aggregator function. I've not seen a very precise way of defining this aggregator function, but I think aggregator function describes the meaning of this function, so I always use the term aggregator function, even though I don't know the official terminology is not aggregator function, it's just like function argument or so. But I think aggregator function, it suits well. And then we have the iterable that we want to aggregate into a single value, so we reduce the iterable to a single value. This is the overall idea of the reduce function. So now let's have some examples. Where can you use it actually? So to solve which problems. So they are often, like, as you know, I have written this book, the Python one-liners book. You can check it out, Python one-liners. It's from no starch. It's the best book we have written so far. It's also like user rated. They rated like 4.8 stars or so. It's I think it's a very good book. We have like invested thousands of man hours to actually polish the book and improve the book. And that's why it's also a good book. So if you have a small book and put a lot of work into the book, then of course it will be like at least a solid book. And you can check out the user ratings on Amazon or so. They are actually very good. Okay, so enough advertisement for the book. So let's dive into a practical example. So first of all, we can use the reduce function to calculate the factorial. And do you know that the factorial is like this 6 faculty, for example? Yeah. So and what does it mean? Basically, it means 6 times 5 times 4 times 3 times 2 times 1. So this is a definition of the faculty function. We can use the reduce function to do it for us. So how do we do this actually? So it's very simple. It's a very simple one-liner does it for you. You call reduce. Actually, we don't even need the print function in this context. So we call reduce, and as you know, we need to define the function, and we need to define the iterable. So what do we want to reduce here? Basically, if you want to calculate the factorial up to 6, then we would use the range from 1 to 6, right? So we have now we have actually no to 7 because the stop argument is not included. So now we have the values 1, 2, 3, 4, 5, and 6. Okay, so let's maybe calculate the factorial up to 5. So we would use as a stop argument, we use 6. So we calculate 1 times 2 times 3 times 4 times 5 because it's just easier to compute. And so this is like our input value, the iterable to be reduced. And now how do we want to reduce it? Basically, we need to define a function, and we use the anonymous lambda function to do this. So we have lambda, we have 2 arguments. As previously, like the aggregator function previously, we explicitly defined it using the def keyword. But now we can also implicitly, just dynamically pass the function object without even assigning a name to the function object, we just pass a function object into the reduce function. This is the common way of doing it actually. And here our function takes two arguments, x and y, so two values from the iterable that need to be reduced to a single one. And then how do we reduce it? So you can now pause the video and try to figure out what I have to put in here in order to implement the factorial function or faculty function. So you can also, yeah, you can pause the video. So basically it's just a multiplication of 2. So why is that? Because if we start with the sequence 1, 2, 3, 4, 5, now we take the first sequence element and we multiply it with the second one, right? 1 times 2. And then we multiply it with the third one. So the result of this 2, we multiply with the third one, so with 3. So we have 2 times 3. So 2 times 3 is 6. So we take the result 6 and multiply it with the next one, 4. So we have 6 times 4, which is 24. We take those, like 24, and the only remaining value from the iterable 5, 24 times 5, which is 120. So we have the overall result 120 of the reduced function. So let's check whether this is the case. Yes, this is the case. Okay. So this is how you can implement the factorial function in a very concise, beautiful one-liner. Nice, right? Isn't it? So we can do this like very concise one-liners that solve some math problems even in a one-liner. But let's have another one. Say we want to take a list of values. So for example, list 1, 2, 3, 4, and expand it to like a list of lists. So for example, like this. So we take basically we take the first value y, and then we simply take all the values, the subsequent values up to y, but y excluded. So for example here, for this value 1, we basically create a list of the element 0 with 1 element. For element 2, we take a list of 2 elements. For element 3, we create a list of 3 elements. And for element 4, we create a list of 4 elements. These are just some dummy problems, but they will help you improve your skills and improve your understanding of the reduce function even more. So how can we actually accomplish this? So now maybe I should comment this out, because otherwise it will throw an error, and then we will just accept it so that you always know what we want to accomplish. This is what we want to accomplish. Basically, again, now let's do the same. We have the reduce function. The first argument of the reduce function is the function itself, the aggregator function. Then we have the iterable. And now you will also see the use of the third argument, which is the initial value. So I call it initial. And our initial value is the empty list. So now if you have an initial value, then the reduce function, the initial value for the reduced function, like in this case we have x and y, we will pass as initial value, we will pass the first time, we will pass the initial value as x. So in our case, so previously the initial value was like 0, yeah? So we pass 0 as the initial value, then we aggregate 0 with the value y, which is the first value of our list. So we have 0 plus 1 is 1. So actually in the first execution we would calculate 0 time like 1. Actually, per default, it takes the first list element as the initial value. But now we explicitly define the initial value, which is now an empty list. So now what does it mean if we now put an empty list into the as a value x? We can basically do some list concatenation and like advanced stuff on lists in our function. So as iterable, again, we use our list like 1, 2, 3, 4. And now we want to reduce this thing to that thing. It doesn't look like a reduce function, but we can do it. It's very powerful, as I said. So let's define the lambda function. Again, the lambda function always takes 2 arguments, x and y. And now we need to simply define the return value here, simply. So this is now our challenge, to actually go from this list to that list within the lambda function. So we need to define 2 values, reduce 2 values to 1 using so that when repeatedly reducing these values, we obtain this list. So how do we do this? Basically, it's so we should. The easiest way of basically what we want to accomplish is to do some list concatenation. Okay, so we take the initial list so x will always be a list, because initially it is a list, and then we return a list itself by using some list concatenation operation. So actually the return value will be a list, so that repeatedly you obtain like the overall result is a list of elements, and the elements should be lists themselves, okay? But so therefore like the overall structure looks like this at this point. So we have our element x, and we use the plus operation to concatenate our list with a new list. And we will define this in a moment, but I just want to give you like the idea how it works. So basically what we are doing is, initially it is the empty list. Now we use the empty list and we take the first element, which is 1, and we create a list of one element, which is this one. Now we need to concatenate the empty list with the list of this one list to obtain, so how can I, no. Yeah, to obtain this list of, so maybe let's have a comment here. So basically we perform this operation first, and this will then yield our list with one element, which is the first step, right? So now we have this aggregated value, and now we need to put another value, like to concatenate this with another value by concatenating it with the next one. So we need to perform the next reduction. So we take this and we add to this the list of lists with two values from 0 and 1. Okay, now I actually did this wrong, so this should be 0, right? So now, and then again, if like the result of this concatenation is the list of two inner lists, like a list of lists, 0 and 1. And then we use this list of lists as input. So this is now our x value, and we add to this our y value, and the y value, basically the y value is now the element 3 in this case. So we need to create a list with 3 values. So we want to create this list 0, 1, 2, and we concatenate those two lists of lists together so that we obtain this list. And now we take this as an input argument to x, and we, as y, we again have the value 4. So we create a list with 4 elements. So we have a list of lists with 4 elements, 1, 2, 3, 4, 0, 1, 2, 3, and we concatenate those together so that we obtain this list, and this is our final result. So you see, the aggregated value is a list of lists. Okay, so therefore we have a list. We start with the empty list and we aggregate this, and we add a list to the list of lists. So we always add two lists of lists together to obtain the final results. So this now gives us our goal, what we want to accomplish. So we have z for z in range y. Basically, could be probably simpler. So maybe we can even have like list range y. Okay, so this should work, right? So we create x is a list of list always. So we can always assume that x is a list of lists. Initially, it's the empty list, which can be seen as a list of lists, and then we add a list of lists to the empty list, and this is this. So we have the square bracket notation, the outer square bracket notation, which indicates that it is a list, and we create a new list and put it into the square bracket notation, and this list is just a list of consecutive values from 0 to y. Y is excluded, so we have, so for example, if y is 2, we get the list 0 and 1, and we put this list into our outer list, and so obtain a list of lists. And just by repeating this procedure, we actually aggregate the whole we aggregate those list of lists together, and we obtain this expansion of our original list. So let's check whether this actually works, and it works beautifully. So we have we reduce this inner list, like here we put this inner list 1, 2, 3, 4. We expand it into a list of lists with as many elements as are defined as y values. Okay, so we could also like use, maybe let's copy this, check out different y values. Now we could use, for example, 4 and 5 and say 6. So now this will be a very huge list. So you see, now we have like a list of 4 values first, then we have a list of 5 values, list of 6 values, and list of 4 values. Okay, so this is how you can use the reduce function to even like aggregate some lists of lists, aggregate some information on the way. So it's very like advanced stuff. And if you didn't understand it, no worries, you can watch it again. Now you probably get even more out of it the next time you watch it, and then you can watch it again. This is so advanced that I actually seldomly find some videos about how to use the reduce function to do these advanced things. Okay, so now let's maybe have another advanced reduce function, which is to calculate the power set of a set. So say we have given a set S with 3 elements. Now we want to calculate the power set of this set. So what is the power set? The power set is a set of all subsets of this set. Okay, so in this case the power set would be, in the power set we have the empty set, we have the set of 1 element, which is 1, set with 1 element 2, and set with 1 element 3. Then we have the set with 2 elements like 1 and 2, and 2 and 3, and 1 and 3. And then of course we have the original set, which is 1, 2, 3. So this is the power set of our given set. And this is a very popular interview question, how to calculate the power set of a given set. And if you could actually solve it as a one-liner, this would be great. This would be very impressive, and the interviewer would probably hire you right away for being able to develop such smart one-liners. Okay, so how does it work now? Our one-liner, basically this is quite advanced, so I will just go over it. So we create a function PS for power set, and it takes as input a set, right? And as output we use the reduce function as an output. So we reduce a set to a power set using approximately the same strategy. So we have the function, iterable, and initial value. As iterable, what do we use? We use the set S, right, as an iterable. As the initial set, we create a list of sets, a list of a set. So we have, because we cannot create a set of sets because the set requires hashable values. So later we want to create a power set, but actually the power set as a data structure is impossible. So basically what we want to do is replace this outer set, outer curly brackets with the square brackets, so we have a list of sets, and this is like our power set list or so. Yeah, so we create a list of, initially it contains only the empty set, and now we expand this list subsequently using our function. Now we need to define the function. The function, again, it takes 2 arguments. We can call them whatever we want, and we then have a return value. So our 2 arguments are now the current power set. So we gradually build the power set, and we pass another element, so an element of our original set S, one by one. So we, for example, pass the element 1, pass the element 2, pass the element 3. And then we return something. So what do we return? Again, we perform a list concatenation here. So we concatenate to our current power set a new list. And what do we put into this list? Now we basically perform subset and X. So this is a union operation for subset in P. So I'll explain it in a moment. So we basically use list comprehension to create a new list, and we create a list of sets. Yeah, so we have in our expression and context. So as context we iterate. So we create a new list, and for each basically subset, for each subset we have already created in our power set. Initially it is only the empty set, but then later we will have added some other sets. So we go over all sets we have already created and add an element to this set, yeah, using the union operation here with this or union operator. So we basically take the element X, which we put, like, we go element by element. First the first element will be X equals 1. So now first we take this element 1 and perform the union operation on the subsets we already have. Initially, it's the empty set, so we have the empty set, and we perform union on the empty set union with the element x, which is 1. So we have a set, we have the empty set in our power set, but then we also have the set with one element 1. Okay, and then we repeat this. So we basically create a list of lists. So in this case, we have so maybe we should have an example here. I will just create a multi-line string where I can show you the example. So initially, we have a list of an empty set like this. Yeah, so this is our first step. But then in the second step, we take our element y is now no, it's actually called the element x. So this is our p. Yeah, initially our power set p only contains the empty set. Sorry. And in the next step, so we set our element x to the value 1, yeah? So this is the first value of our set S. So initially it is 1. So now we go over all sets in our power set. Initially there's only 1, and add the union. So basically here we do a union of our subset. We go over all subsets and perform union with our element x. So we have our original power set plus, so this is our original power set plus our new sets which we need to put into our power set, which is only one set, the set with the element 1, yeah, because we perform union on our existing set with the new element x. And this, of course, yields the set, the list with 2 sets, the set with 0 elements, so the empty set, and the set with 1 element 1. So this is the first step for x equals 1. Okay, but then the next step, x equals 2. Okay, so we go over all sets. So we use our existing power set, which is this one, and we add to this the list of sets that arise if we add one more element to those sets. So initially, we add the element 2 now to our empty set. So we get another set 2, and we add the element 2 to our set with 1 element 1. Okay, so now we add those two elements to the power set to obtain the new power set with those 4 elements. Okay, so I will not write them out. So now, because I write them in the next line, so in the next line we have x equals 3, and the result of this operation will be this set. And now we concatenate the new list of sets that arises if we add the element 3 to all those sets that we already have. Yeah, so we have the set with 1 element 3, we have the set 1, 3, we have the set 2, 3, and we have the set 1, 2, 3. Okay, to obtain the final set, let's copy this again, because now we don't have any element left. The final set, a power set, which is this one. Yeah. So how does it work conceptually? So the idea was to actually, in each step, we create all sets with the current element, all possible power sets with the current element, using all power sets we have previously created, and over time, so we build the power set of all possible power sets. Sorry. Okay, so that's it. This is how it would work actually, and so let's see. Let's close this multi-line string, and okay, now it just reflects back the multi-line string I've created previously. But we have, like in this function ps, we have created a function that creates a power set for a given set. So we can, for example, pass 1, 2, 3, or pass simply our set S, which we have previously created here, of 3 elements, and we obtain our power set. Very powerful function, right? And we can also pass like sets with only 2 elements, for example. We can pass set with 4 elements, and you can see like nothing explodes as like the number of elements in the power set explodes exponentially. So it's really it's really a very, very expensive operation. So you cannot probably, for 10 elements, it wouldn't even work. So let's check. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Boom. Okay, so it still works. 128 lines, so it's a huge set of sets, yeah, because it's like combinatoric explosion of the number of sets in our power set with 10 elements. So it grows so quickly. So I'm almost sure that for 100 elements we cannot do it anymore. Let's actually prove my claim. So we create x for x in maybe let's just do the simpler one, set range 100. So now we create a set with 100 elements. Here, pass it into the set function. Now let's try this. Okay, now it calculates, and probably it never stops because it's such a complicated operation. It contains so many sets that it will just explode. It will just my memory is not capable of handling it anymore. Okay, so that's it. I think now you should have understood at least the basics of the reduce function. It was a very, very complicated video, so go ahead and watch the video again so that you can really master the reduce function and functional programming, and probably you learn a lot of new techniques and things you haven't known about by just re-watching the video again and again. Okay, so thanks for watching the video and see you in the next video. Bye.